Example 5 wants us to graph something very similar. Instead of y equals 2 to the x power, now I need to graph y equals 2 to the negative x power. So again, if we go into our graph, I'm going to change my exponent to a negative x and hit graph. So here we can see we have a decreasing graph. And so let's get our table of values. So second table. And the first one I can fit on here is this negative 3/8. So I'm going to go negative 3 to 2. Negative 3 to 2. And then what are my y values here? We have 8, 4, 2, 1. I'm going to write that 0.5 as a 1/2, and then my 0.25 as a 1/4. Okay, so you can see here that now my values are getting cut in half. Half of 8 is 4, half of 4 is 2, half is 1, half is a half, half is a fourth. And the reason is this really isn't quite in quote standard form. We typically want that exponent to be positive. So another way to write this would be y equals 1/2 to the x power. Okay, when this is negative, we can change this exponent to become positive if I take this 2 and put it down here in the denominator, and then I need a 1 as a placeholder on the top. And so now I have a base of 1/2, and so that's why everything here is getting cut in a half. So I'm going to plot these points now. And as you can see, as our x's are getting bigger, my y values here are getting smaller and smaller. If we keep cutting these in half, that's going to be 1/8, 1/16, 1/64, and or 1/32, then 1/64. So again, we have a horizontal asymptote right here at y equals 0. So when I connect these, I'm going to make sure that I do not cross that x-axis there. So there is my wobbly line. What is the domain? As I go from left to right, I go arrow to arrow. So my domain is negative infinity to infinity. And then my range, as I go from the bottom to the top, the first thing I hit is that asymptote. And so again, what an asymptote is, it's an imaginary line that my graph is approaching, but never touching, never crossing. So we're going to go 0 to infinity. That 0 needs parentheses because it's never going to include 0. Again, if that horizontal asymptote is on my x-axis, then I'm not going to have any x-intercepts. And that also works if that horizontal asymptote is above, right? So if we look at example 4a, when that horizontal asymptote was above the x-axis, then it's never going to cross that x-axis either. And then what is my y-intercept? Well, where is it crossing this y-axis? Right here at 0, 1. So let's look at some more graphs of what we have when we have a decreasing graph with a different base of 1/2. So let me stop sharing this screen and we will share Desmos again. I'm going to go here. So this is what we just graphed, this 2 to the negative x power, which is the same as 1/2 to the x. So when I have 1 cubed, now that's going to again be steeper because now everything's not getting cut in a half, but it's getting cut by 3. So same thing for a fourth, everything's getting cut by a fourth or divided by 4. And then 1/5 to the x, 1/6 to the x, and 1/7 to the x. These graphs have the same things in common. They are all decreasing because that base is between 0 and 1. They all have the same y-intercept at 0, 1, because again, anything to that 0 power is 1. And then they still have that same horizontal asymptote at y equals 0. And one more time, we cannot have a base of 1, because if we have a base of 1, 1 to any power is just 1. So it's a horizontal line. You can again start making these decreases a little bit more shallow the closer you get to 1. So if I have, let's say we have 0.5, so if I have maybe 0.7 to the x, that gets a little bit more shallow. 0.9 to the x, oops, to the x, oops, come on, no, 9 to the x, there we go, even more shallow, but you can still see that is decreasing, just decreasing not nearly as quickly. So the closer these numbers get to 1, the more leveled out they get. The further they get from 1, the more steep they get right there. So what am I doing? Okay. Okay, so these are going to be decreasing when my base is between 0 and 1. And those are the wrong inequality symbols. Let's try the other one. Okay. So when my base is between 0 and 1, you will always have a decreasing exponential like this one right here.